Hello everyone, my name is Lakshman. I am pursuing my degree in the CSE department of the SVC College, Bangalore. Today, I am here to explain a PowerPoint presentation on the selection sort algorithm. First, let us see what is an algorithm. An algorithm is a set of commands that must be followed for the computer to perform calculations or other problem-solving operations. According to its formal definition, an algorithm is a finite set of instructions carried out in a specific order to perform a particular task. It is not the entire program or code. It is a simple logic to a problem represented as an informal description in the form of a flowchart or pseudocode. Basically, we represent the algorithm to find out the logic and the variables used in the program. We start from the step 1, which is the start, and we include the variables used in the program and the main logic of the program, and it ends the algorithm by using the stop step. Basically, when we write a program, we should see that we can reduce the space complexity and time complexity of the program execution. In this slide, let us see how does an algorithm work. Algorithms are step-by-step procedures designed to solve specific problems and perform tasks efficiently in the realm of computer science and mathematics. These powerful set of instructions form the backbone of modern technology and govern everything from web searches to artificial intelligence. Here's how an algorithm works. Input. Algorithms take input data which can be in various formats such as numbers, text, or images. In the computer languages, we input the data basically in the computer language code, we input the data in the form of integer type, float, character type, and double. Processing. The algorithm processes the input data through a series of logical and mathematical operations, manipulating and transforming it as needed. So the processing is based on the logic that we used in the program, and it is the main part of the program and the algorithm used. Output. After the processing is complete, the algorithm produces an output which could be a result, a decision, or some other meaningful information. After processing the logic and performing the code execution, we get the output. Efficiency. A key aspect of algorithm is their efficiency, aiming to accomplish tasks quickly and with minimal resources. As I said before, the execution of the code basically focuses on the space complexity and time complexity reduction and using minimal resources. Optimization. Algorithm designers constantly seek ways to optimize their algorithms, making them faster and more reliable. Implementation. Algorithms are implemented in various programming languages, enabled in computers to execute them and produce desired outcomes. In the last step, we come across with the implementation is in C. In computer, we use various languages like C, Java, Python, and C++, and the algorithm can be executed in any language in the computer. Let us see one basic example for an algorithm. Problem stated is create an algorithm that multiplies two numbers and displays the output. Basically, for multiplication of two numbers in programming, we need two integer data types. Step 1 is start. We start the algorithm from the step 1 start. Step 2, declare three integers x, y, and z. X and y are the values used for the multiplication and it is stored in the z. Define the values of x and y. Step 4, multiply values of x and y. Step 5, store result of step 4 to z. Step 6, print z. And step 7 is stop. We end the algorithm from the stop step. Basically, when I give the value of 10 to x and 8 to y, the product of 10 into 8 is 80 and the value 80 is stored in z. So this is the example for an algorithm. Now, let us come to the main topic of the presentation, the sorting methods. A sorting algorithm is a method for reorganizing a large number of items into a specific order such as alphabetical, highest to lowest value, or shortest to longest distance. Sorting algorithms take lists of items as input data, perform specific operations on those lists, and deliver ordered arrays as output. Example is unsorted array is given as below 1, 4, 5, 9, 3, 7, 2, 8. And after sorting, the sorted array is 1, 2, 3, 4, 5, 7, 8, 9. And as we can see in this picture, these are some of the types of sorting methods. The first one is selection sort, the next is insertion sort, heap sort, radix sort, merge sort, quick sort, and bubble sort. These are some of the sorting methods used in C programming. Now let us come to one of the sorting methods, that is the selection sort. Selection sort is a simple sorting algorithm. This sorting algorithm, like insertion sort, is an in-place comparison based algorithm in which the list is divided into two parts, the sorted part at the left end and the unsorted part at the right end. Initially, the sorted part is empty and the unsorted part is the entire list. The smallest element is selected from the unsorted array and swapped with the leftmost element, and that element becomes a part of the sorted array. This process continues moving unsorted array boundaries by one element to the right. This algorithm is not suitable for large data sets as its own average and worst case complexities are of big O n square, where n is the number of items. And as we can see in the right side, this is the algorithm for the selection sort. Now, let us know the time complexities of the selection sort algorithm. The best case complexity. The selection sort algorithm has a best case time complexity of big O n square for the already sorted array. Average case complexity. The average case time complexity for the selection sort algorithm is also big O n square, in which the existing elements are in jumbled order. The worst case complexity is also big O n square, which occurs when we sort the elements of an array into the ascending order. Now, let us see one example for selection sort. As we can see in this picture, in the step 1, the unsorted array given is 7, 5 and 4, 2. And the minimum element in that array is 2. So, the first element 7 and 2 are swapped in their positions. And the sorted array is 2 and the unsorted array is 5, 4 and 7. In the next step, 2 is already sorted and it is placed in the minimum position. The next element is 5 and it is compared with 4. So 4 is less than 5. So the positions are swapped. So now the sorted array becomes 2 and 4. The unsorted array is 5 and 7. In the next step, 2 and 4 are sorted. The next minimum element is 5. So 5 and 7 are compared. So 5 is less than 7 and it is placed in an order. So 5 is combined with the sorted array, 2, 4 and 5 and the unsorted array. In step 4, no other element is present in, so 7 is the minimum element and it's combined with the sorted array. So the total sorted array is 2, 4, 5, 7. So this is the example for the selection sort algorithm. We have reached the end of the presentation, guys. Hope you like my presentation on the explanation of selection sort algorithm and its example. Let us meet in the next presentation. Thank you.